Alright, so again, still dealing with electronegativity. This means that an atom that is small has lots of protons, so like fluorine, and it will have a very large amount of electrostatic attraction or electronegativity to the electrons of another atom. Okay? Big atoms have lots of protons, but they're shielded by the inner levels of their electrons. Therefore, they have a small amount of attraction or electronegativity for the electrons of another atom. Alright, so this is kind of hard to understand when we haven't really looked extensively at kind of sizes and shapes of like electron energy levels, but we'll kind of get into that, and it'll make a little bit more sense when we look into there. Okay, so if we look here, we've got the nucleus of cesium, okay, and then we have the valence electrons of silicon. Okay, here's the distance between the nucleus of cesium and the valence electrons of silicon. So there's quite a large distance in there. And if we're going to compare that to the nucleus of fluorine and the valence electrons of silicon, we've got a smaller distance between the nucleus of fluorine and the valence electrons of silicon. Alright, so that's because fluorine's so much smaller, there's less shielding of those electrons. So you can see there that the electrons are pulled towards the silicon. Okay? So bonding type and electronegativity. Electronegativities can be related to bonding types. Okay? Ionic bonds occur between metals and nonmetals. Metals have low electronegativities and will lose electrons, while nonmetals have high electronegativities and they will gain electrons. Okay? That should be kind of switched around here. So electronegativities and will gain electrons. Okay? The two ions that are formed will attract each other and they will form a chemical bond. Okay? Covalent bonds occur between non-metallic atoms. So if you look at two atoms that have the same electron negativities, like hydrogen gas, the two nuclei of the atoms will attract the electrons with exactly the same strength. And then the electrons are shared equally between the two atoms. So here we've got our two hydrogen nucleus, and you can kind of see there with the depiction there of the green that kind of the electrons are equally shared in between these two nucleus. But when two nonmetals that have different electron negativities share electrons, the sharing is no longer equal. Okay? The element with the higher electron negativity pulls the electrons closer to itself. Okay? So here got fluoride, and it's got larger electron negativity, so it's going to pull the electrons closer to it. So we can see there that the electrons are kind of in this egg shape, more around the fluorine and less around the hydrogen. Okay? So the result is that one end of the bond ends up having a slightly negative charge, okay, and we represent that with that symbol there, and the other end of the bond having a slightly positive charge, which is represented by that symbol there. Okay, so we would show here in hydrogen chloride or HCl that the hydrogen side has slightly positive charge, the chlorine side has a slightly negative charge. Okay, so bonds have unequal sharing of electrons are called polar covalent bonds. Okay, they are also called bond dipoles since the bonds have oppositely charged ends. Alright, so we're going to look at how to show these bond dipole arrows in the next video.